Okay, work. Right now we have the definition of work, which is the product of the force and the distance moved in the direction of force. So in this case, simple case, point A move to point B, and there is a force pushing it there. It is moving to the right. The force is acting to the right. So the direction of force and the direction of motion is the same. Therefore, we can calculate work done by this force equals to the magnitude of the force times the distance moved over here. Okay? So the units are shown, work done, units in joules as well. Does this sound familiar? When do we see units of joules also? Energy. Energy and work done, they have the same units, which is joules. So force will be in newtons and distance measured in meters. So example over here, this lady pushing a stroller. She is exerting a force to the right, it is moving to the right. So there is work done by her. What about the direction of applied force and the direction in which the object moves? They are perpendicular to each other. So earlier on in our worksheet 6b, we saw that the weight is pointing downwards, but it is moving to the right. So they are perpendicular. So when it is perpendicular to each other, there is no work done. So another example will be this boy carrying the books. He is exerting a force upwards, right? Because you can just imagine you carry the book, you are exerting a force upwards. You are trying to counter the weight of the books, which is downwards. That is why after you hold it for a long time, your arms get tired, you feel like putting them down. You don't feel like exerting a force upwards anymore. So in this case, the boy exerting a force upwards when carrying the book, but he is moving forward. Okay? He is not pushing the books upwards, he is not letting the books go downwards. He's just holding them stationary, but he is moving forward. And we see that these two directions, they are perpendicular to each other. Okay? So work done will be the force upwards times the distance moved upwards, which is 0. So it is 0 joules. Any questions so far? Afiq, okay? Okay, another case is when no work is done when you apply a force, but there is no motion. For example, a person pushing a tree, a very big tree. So the tree does not move even though he is exerting a force. So we say that you haven't been doing any work because there was no distance moved. Again, a girl carrying a pile of books, but she's not moving. Also, no work done. Okay? In both instances, the distance moved are 0. So now we have an example. A boy pushes a box across a rough horizontal floor. He exerts 5 newtons to move it 2 meters. So what's the work done? First thing we need to write will be force times distance moved. And you must keep in mind, distance moved in the direction of the force. Force pointing to the right, moving to the right. So yes, we can apply it. 5 times 2, you get 10 joules. Okay? Yang Kun, okay? Now, I have a slightly more complicated example. There is a slope, and I have the box initially at rest at the bottom with mass of 2 kilograms. It is being pulled up the slope by 26 Newton force. Something is pulling it up. Final speed when it reaches this point is 8 meters per second. Distance moved by the box along the slope is 4 meters. Wow, looks quite a lot of information. Let's see what they want. Calculate the work done by the 26 Newton force. Okay, how do we find the work done by this force? Force times distance moved again in the direction of the force. What is the distance moved in the direction of the force? 4. So answer 26 times 4. Okay. So part A, 26 times 4, you get 104 joules. Straightforward, huh? Now, for part 2, calculate the gain in kinetic energy in the box. Initially, it was at rest, so kinetic energy was 0. Finally, when it reached the top, it had a speed of 8 meters per second, meaning we can calculate the kinetic energy. Formula is given by half mv squared. So just using that, half times mass, which is 2, times 8 squared, we get the gain in kinetic energy. Okay? Am I going too fast? No, huh? Part 3, the gain in gravitational potential energy. Formula is mgh. G is 10, h is 2. Mass is 2. So, gain in GPE is 40 joules. Straightforward also. Now, what I need you to pay attention to will be this part. State and explain the significance of the values obtained in part 1, part 2, part 3. Okay, so what do you think? Work done by the force is 104 joules. At the end of it, it gained kinetic energy of 64 joules. It gained gravitational potential energy of 40 joules. So, what do you notice about these numbers? Okay, they are different. What else? What else do you notice? KE plus GPE equals to? Makes sense, no? The person exerting a force of 26 newtons did work. He did work. How much work did he do? He did 104 joules. All this work is converted into two types of energy for the box. First, converted to kinetic energy. As shown, finally it had kinetic energy of 64 joules. And it is also converted to gravitational potential energy of 40 joules when it reached the top. Okay? So that's why we have our energy that is conserved. Okay, so with that, I want you to continue page 52, 53 at home. That is your homework. Okay, worksheet 6B, page 52, 53. Because all of these are on work done. We have one last part, which is power. Page 52, 53 for your homework. At the end of the lesson, I will give you more homework. Yeah. Because you have many days until your next lesson. Okay, so last part, it is on power. So far, do you have any questions on energy and work? Any questions? What is the relationship between energy and work? Can you give me a sentence that links energy and work? No, they are not the same. Energy is the capacity to do work. Energy is the capacity to do work. When you are full of energy, you can do more work. No energy, can't do work. So it makes sense that these two quantities, they are measured in the same units, which is joules. Okay? Then now we have a new term, power. What is power? This is the definition. You need to know this. Let's find it in your textbook. It is in page 118. Okay? Highlighted in the box. Put a star beside it. Power is defined as the rate of work done or the rate of energy conversion. Have you all seen or heard of this phrase, rate off? When? When do you hear it? Huh? When do you all hear this phrase, rate off? Which topic? Rate off? Rate of change of speed. What is that? Rate of change of speed is your acceleration. What else do we have? Rate of change of distance, or rate of change of displacement. That gives us our speed or displacement. So what is it about this phrase, rate of change? It just tells us we need to divide by time. Right? You see your acceleration. We say it is the rate of change of speed. So what is the formula? Final speed minus initial speed divide by time. Right? Your rate of change of distance, which is your speed, what is it given by? Your final distance minus your initial distance divided by time. So power is the rate of work done or rate of energy conversion. So what are we expecting for the formula? It will be work done divided by time, which is the same as energy converted divided by time. So this phrase, rate of, generally it means divide by time. So when you know the definition, it helps you remember the formula. When you know the formula, it helps you remember the definition also. Okay? So these are the different quantities and their units. Of course, time will be in seconds again. Okay, so example, an engine, maybe a car engine, it does 60,000 joules of work in 10 minutes, determine its power. So formula, work done over the time taken, change time taken to seconds. And you get 100 watts. Easy, 1-2 steps only. Okay? A kettle is rated. You can go and check your kettles at home. They should tell you the power. Okay, so in this case, 1850 watts. Determine the maximum amount of thermal energy it can generate in 1 hour. So we are talking about change in the energy type, electrical to thermal energy. Okay, so we write down our formula again. Power equals to the energy converted over the time taken. Fill in all the numbers, solve for the energy. That's all. Oh, and that's all for power. Okay, only one formula to remember. This one for power. Alright? So with that, you can continue with worksheet 6C, D, and E. 6C, D, E. This is due on Wednesday, your next lesson, which is 6 days later. That is why there is more work given today.